right. So the 4-5 notes, we're going to start out by messing around with our graphing calculator. So I have my graphing calculator here as well. I want you guys to go to the y equals. Let me see if I can kind of dual screen this up here. Okay, now we're not going to do these all at the same time because then it'll just be too much to look at. We're just going to look at the first one. So let's do parenthesis and then x, which is this button right here. That's the x button. Plus 4, close parenthesis, and then I just hit the x squared button, which is right over here. And then we're going to go ahead and we're going to graph this. Now, I have no idea what my window is at. So my window right now is something that I used in a different class. So my window is all messed up. If your window isn't like a nice 10 by 10 window, it's actually 20 by 20, but the 10s, then you can just hit zoom 6 and it'll fix your window. And there's my graph now. So this is what I got. It has a power of 2, so we can see it's quadratic. It is a parabola. But that power of 2 tells me how many solutions should I have. How many solutions should I have for power of 2? We just discussed this on the last notes. How many solutions will a power of 2 give us? 2. But if you look at the picture, there's only 1. Why? If you look at the equation, why is there only 1? But I should have 2. Why is there only 1? Okay, if we don't know, then let's solve this. Let's set this equal to 0 and let's solve it. Brooke, you know why? No. It's not going to be 2. If I extend this x plus 4 squared, if I expand it, I'm just going to have x plus 4 and x plus 4. So they would be what? They would both be equal to what? -4. So we would have 2 solutions, but they're exactly the same solution. And since they're exactly the same solution, I can't really tell from my graph. Although, actually, we can. We can tell from the graph, and that's what we're learning today. So today, I'm going to write x equals -4 twice. Today, we're going to talk about repeated solutions. So we're going to go back to this graph and go back to y equals. And now we're going to change our exponent to a 3. So this tells us we should still have an x-intercept at -4. We should have 3 of them, but they're all the same. So let's see how that changes our graph. So now what happened is right at -4, it's not a parabola anymore. It's not a parabola anymore. Do you know what shape it actually has? X plus 4 kind of went down and bounced. Squared, I'm sorry. And then x plus 4 cubed passed through, but it kind of changed the behavior of the graph right there. It looks like a cubic graph right there at that -4. And in fact, it is a cubic graph at -4 because we just take our cubic and move it 4 to the left. That's what it is. It's a cubic that is moved 4 to the left. So now let's do the 4th power. I think I'll change that to a 4. And it went back to looking kind of like a parabola, but it isn't because it's to the 4th power. If I graph the parabola and the 4th power at the exact same time, you don't necessarily have to. But if I graph mine at the same time, oops, sorry. You can see they are different. Okay, you can see they are different. They both hit that -4 in one spot, but the quartic is like flatter on the bottom, and then it goes up faster. All right, let's go back to y equals, and let's type in some of the other side. So we've got x multiplied by x minus 5. How many intercepts, how many solutions should we have for this one? If we set each factor equal to 0, how many should we have? Somebody say something. 2. Thank you. We would have x equals a 0 and a 5. So we hit graph, and that should validate what we just said. X equals 0 right here, and x equals 5. We've got our 2 x-intercepts. What happens at the x-intercept is the graph just passes straight through. Now what we're going to do is we're going to change that. We're going to go and we're going to change it so it is just x, but then x plus 5 is squared. So we've only changed the x plus 5. So at 0, it still just passes through. But at 5, there's 2 of them. And it does a parabola because there's 2 of them. So it touches it and it bounces back off. We go and we change it to x minus 5 to the 3rd. I haven't changed the x at all, so it should just pass through the x. But at x minus 5, at the x equals 5, it now has a cubic shape right at that x equals 5. Because there's 3 of those 5s, it makes a cubic shape, even though the whole thing is not a cubic. It makes the shape at the x-intercept of how many repeats it has. Go back to y equals, and I'm going to do one that's not on the worksheet. So I left the x minus 5 as cubic. I just left it, but I made x squared. If I make x squared, that means there's 2 answers at 0. If there's 2 answers at 0, the shape at 0 should be a parabola. It's really skinny though. Really skinny, but it came up and it went back down. I can make it so you can see it better. There. The shape came up, went back down, and then we did a cubic through 5. So the number of repeated solutions tells you what the shape at that x-intercept is going to look like. The number of repeated solutions tells you what the shape at the x-intercept is going to look like. If there's one solution, it will pass through. Two solutions, it will make a parabola. Let's say bounces. It'll bounce off of it. Three solutions. Cubic shape. Bless you. So we are going to solve we're going to solve a polynomial equation by factoring it. We're going to do that by factoring it. We're going to do that by factoring it, okay? What's our first step of factoring? GCF. Do we have a GCF? What is it? 2x. We're going to pull that out. And pulled out the 2x. And I have x squared minus 6x plus 9 equals 0. So my next step is this trinomial. We're going to factor it. You can just factor by guess and check. Got to have an x and an x. The minus sign and plus sign tells me minus minus. What's going to make 9? What do I get? 3 and 3. So one more step. I've got 2x, x minus 3 squared equals 0. So that is factored. So if we're going to solve it, we're going to say 2x equals 0, x minus 3 equals 0. And then the other x minus 3 equals 0, I don't need to write because it's the same. Solve these. X equals 0, x equals 3. Now I'm going to talk about what that graph is going to look like, and we're going to sketch a graph before we even type it in our calculator. This is where we're going in this next section, what we're about to do here. What do I know about this graph? I know that we have an x-intercept where? We got 2 of them. Where? 3 is one of them. Where else? And 0. Some more information that I can get from this equation is what we did in section 4.1. End behavior. End behavior. So I'm going to look at the degree, and I'm going to look at the leading coefficient. The degree of this equation is 3. Is that odd or even? Odd. The leading coefficient is 2, which is positive. So if we have something that is odd and positive, my end behavior is going to be like this. My end behavior is going to be like this with something else happening in the middle. So what I can do from these points is I can for sure tell you that this graph is going to look like that on the end. I can also tell you that this graph is going to look like this on the end, because that's the end behavior. And now I can kind of tell you what it's going to look like in the middle. Because we had one solution at x equals 0, that's going to pass through. Because we have two solutions, the -3 is repeated times 2. Because we have two solutions, at that 3, it's going to look like a parabola. So at 3, it's going to look like a parabola. And somehow, these are going to like curve around a touch. This is the part I'm not 100% sure where it goes, but I know for sure it's going to curve around a touch. The part that I know for sure is that this is going to be a parabola and that this is going to pass straight through and the ends are going to go here. I know that stuff for sure. So now go on your calculator or on Desmos and let's type that equation in. We're typing 2x to the third minus 12x squared plus 18x. It was exactly what I told you it would be. We've got passing through at 0. We've got a parabola shape at 3. And we got that from our factors and how many repeated. We got that from the end behavior. All right, we're going to do one more of those and we'll call it quits for today. Okay? Let's do number 1. We're going to do the exact same thing. We're going to solve it, and then we're going to kind of like sketch a graph, and we're going to look to see if it worked. Okay? Solve the equation, and we're going to do it by factoring. What's our first step of factoring? Okay, GCF. So we're going to take out, this is just a 4. Okay, then from here, we're going to factor it. It's going to be both minuses. X to the fourth is x squared and x squared. 9, what do you think? 3 and 3? Or 1 and 9? 1 and 9, right? And those can actually be factored further. So both of these are difference of squares. This one I've seen 4 other times today. X plus 1, x minus 1. And the next one, x plus 3, x minus 3. So we've got differences of squares. And then I can solve it. So the 4 does not give us any answer. When we set each of these equal to 0, I will have -3, -1, +1, +3. So for sure on the graph at -3, -1, +1, +3, we will have x-intercepts. Are any of these x-intercepts repeating? No. So every single one of these is going to pass through. So now I want to look at my end behavior. So the degree is 4 which is even. The leading coefficient is 4, which is positive. And that tells me my end behavior is going to both be up. So I know at the very ends, my graph is going to go up. There's no repeats. So since there's no repeats, each of these is going to just pass through one time, and I have to connect the ends. So in order to pass through this once, but also pass through the next one only once, I have to like turn it around somewhere. And I have to turn this around somewhere, and then I have to turn this around somewhere. It's going to look something like a W. That's how I'm going to pass through each of these once. We can graph it to check it. I'm typing it in. I'm just slow at typing. And you don't really see the whole W because it depends what your window looks like. But for sure, let me see if I can change it a little bit. I don't know if this will work, but nah, that doesn't work because now I can't see below. There we go. I just made my Y's go from negative 100 to a positive 100. Here you can see it. It's not so important about how high up and down it goes. What's important right now is that we can come up with this shape. We did not finish all of section 4.5, and I put on your week at a glance that I wasn't exactly sure what days we would hit everything, but on your module for today, we have our first assignment that we definitely did all of, so you can for sure do this one. And then the second assignment, you can start. I think you can get through, I think it's like through number 10, I think. It's just the factoring and solving ones. You should be able to get through like number 10, but we will finish these notes next time so that you can get all the way through number 20. You do not want to wait and start. You don't want to wait and just start this assignment next time because there's only like a few questions up here. And then you'll just have like way more work to do next time because we're also going to do section 4.6 next time. Okay?